All right, let's talk about eCAL. What is eCAL? eCAL stands for Electronic Calibration, and if you have a nano VNA, you know that you put on an open, short, and then a load, and that's an SOL, open, short, load, OSL. And you can have an open, short, load through, and a lot of times high-end equipment will have a cal thing that you wear around has a lanyard you wear around your neck, and it has the open, short, and load all contained on this one little kind of T thing. You have an open, short, maybe a through, and a load, and it has it all in one place, okay? And so that's sort of what this is. There's a connector on this side, and there's a connector on this side, so you have kind of a T-shaped thing. And this acts as the open, the short, and the load. And it's programmable. So instead of you unscrewing and screwing on and unscrewing and screwing on, this thing does it electronically inside. It has switching inside. So it pretends to be an open, and then it pretends to be a short, and then it pretends to be a load. And that's controlled via USB. And it can't do all those things at the exact same plane, and so it has a lot of electronic calibration data already stored in it. And so it shares that with the host instrument and says, okay, my open is at this plane, my short is maybe a few femtoseconds away from that, and here's the characteristics of my load. It has some lumpiness or something like that. Anyway, this thing is highly calibrated, and then it becomes a transfer standard to your big instrument, okay? So I've never gotten to play with one of these before, so this is kind of fun. So what do we need? Well, we need a USB cable. It comes with a USB cable, and I've been told it's a special USB cable. It has some electronics in it as well. I don't know if it has some type of level conversion, or maybe it even has an eeprom or something in it. I'm not quite sure. Anyway, it has its own special cable, and it says eCAL right on it. So anyway, we are going to try to calibrate our instrument using eCAL. Let's see how we do that. All right, so we're going to calibrate S11, and so that's this connector here. This is our oh, look at that. See my fingers, I touch it. So we are going to attach this to this port here. Now, you could also be calibrating this with cables and have the cables out here, but I want to calibrate right here, so I'm going to put the eCAL on. All right. And here is the cable. The cable's going to go into the side here. There's a couple USB ports, so I'm going to plug it into one of the USB ports. And can you see all of this? Yeah, there you go. So we will be doing network analyzer S11 log mag, and we will be calibrating. We want to have, let's say, 1001 points. Enter, done. We will hit cal. Now we get to this menu here, and you can do simple response calibration, which is just an open or a short or normalization, either on port 1 or port 2, but we don't want to be doing that. There's the user cal, view cal, more, apply nearest, a bunch of stuff I don't understand. We will be doing this one, which says mechanical calibration or eCAL. So if you're going to calibrate it normally with like a nano VNA, have an open short load, you would press this button, and it would tell you what to do. Now this is already set up that it says, this is an N7555 eCAL kit. It already knows it, but normally this doesn't pop up. Okay, and the way that you get here is to hit the button change cal type, and change cal type. This is something else. I'm sorry, but you can do a 1-port, or you can do a 2-port. You can do a short open load through. So you can do all kinds of stuff. Okay, we're just going to do an open short load, let's see, change connectors. Yeah, this is how you get to the eCAL. You say change connectors, and it says, okay, what connector you plug into this thing, and it says all of these choices. Well, we have a 3.5 millimeter connector, so that's fine. And we will hit next, and then it comes up with, well, which calibration kit do you have? And normally it defaults to something like the first one or something, but this one at the top here, it says eCAL. So you need to select eCAL, and you say finish, and then it tells you how to hook it up. So it says, okay, you're going to be doing S11, so you need to hook it up to port 1. You need to hook it up like this. You've got a 3.5 millimeter female connector on the eCAL. Yeah, everything looks good. You hit start calibration. It says connect the eCAL to port 1, and then press measure. And it's done the open short load all in one pass. So we are now calibrated. We are now ready to go. Okay, so I want to be measuring some loads today. And let me take off the eCAL. Now the eCAL is a female. The instrument has a male. And I'll take this off here. And I want to be measuring some male, so I have male to male. So I need to have an adapter. So I have a 3.5 millimeter to 3.5 millimeter adapter here. And so we will screw this on and make sure it's nice and tight. All right, so let's take a look at this. It looks perfectly good. But if we go to measure, let's go to the Smith chart. It should look like a load. It should look like we have just one point over here. It should look like an open, I'm sorry. And it should be one point over here at infinity. If it was a short, it would be over here. Let's see, we could put a short on it and see what that looks like. Haven't done this before. Let's see. I think a short's going to have the same problem. Yeah, shorts have the same problem. Okay, so what's happening? You probably wouldn't have ever worried about this on a nano VNA because it's such small frequencies, but this goes to 26 gigahertz. And 26 gigahertz is a tiny little wavelength. And so you can start going around this racetrack here really, really quickly. And you need to do a port extension if you're going to be using this, this tiny little thing. Even though it's only a centimeter long, it's quite long in electrical length at 26 gigahertz. So what we need to do is we need to do measurement setup, port extensions. All right, so now we need to compensate for the electrical length. So we're going to go to port extensions. So measurement setup, port extensions. We will turn it on. We will go to port extensions here. And now we need to enter some value. We'll use the wheel here. You can see that we're starting to rotate now. And we've gone too far. We want to have it end up right there. So this is 3747. So let's do 40 picoseconds. No, 37. Oops. I went port extensions. There you go, 37 picoseconds. All right, so what are we doing wrong here? We want to be 47 and 60, so let's do 50 picoseconds. We're getting closer, okay. 52 picoseconds. We're getting closer. 53 picoseconds. There we go, perfect. So we've introduced 53 picoseconds to get our Smith chart working at 26 gigahertz. So now everything is looking good. We have it calibrated, we have a port extension. Everything should look great. All right, so let's try a load, okay? I'm just going to grab one here off the bench. Okay. These guys I bought, these are supposed to be good to 18 gigahertz. Oops. It's hard to grab a hold of. Let me put one of my little plastic collars on it here. And yeah, there we go. We're measuring pretty good there. It does have kind of a bigger spiral on the outside. Let's do a, log magnitude. So you can see that we're up to the marker here, we're at minus 30 or 30 dB return loss, and then it starts to get worse up here at higher frequencies. So if we go back to Smith chart, that's what's happening here. Marker. We can see when it starts to loop out with frequency. Okay, it's starting to loop out about right there, right around 15 gigahertz. And, oops. I'm always pushing the wrong buttons. There we go. Yeah, right about there. So somewhere around 20, 25 return loss. It's staying on that tight little spot there. So, but this one is pretty good. Now it's specified at 18, so let's, marker 18 gigahertz. So it's specified to there, so it's definitely below 20 dB. That's usually where they specify these things, 20 dB return loss. But this one's operating quite well even farther out, so this probably would be fine. These aren't calibration loads. These are just dummy loads, right? So you pay a lot of money for really, really good ones. Let's remove this one. And let's try this one. And it looks quite different. It's much, much better down here, but it's worse up there. And if we look at it with the Smith chart, yeah, it's got a bigger whoop-de-doo on it. So I think what I'm going to do is I'm going to go through all of my devices here and measure them and keep record of everything. Now that I have something that works up to 26 gigahertz. I did find one. I think it's this one here. Let's see. Let's see if it's the one. Nope, it's not that one. I have one that's magical. I need to mark these somehow. Maybe I can use a little... there we go. That's my magical one. So even at 26 gigahertz, it's doing very, very good. Log mag, yeah, everything's under minus 23. So yeah, that's my magical device up there. And you can see here. So can we scale the? I don't think this allows me to scale the. Oh, it does. Okay, let me do it that way. Yeah, you can see the final little whoop-de-doo there. All right, I just kind of wanted you to see the eCAL in action. I could do a full 2-port one with 2 cables and do the whole thing, and I mean, there's really nothing to show. It just does it automatically. But yeah, these are pretty nice. I don't know how much you pay for one of those things. I bet you they aren't cheap at all.